Good morning, students. Welcome to chemistry class. Once again, I'm here to discuss with you electronic configuration. And today we'll discuss electronic configuration of higher elements after atomic number 30. So let us see how you can predict and how you can write electronic configuration for higher elements. So as we have discussed up to zinc atomic number 30, and we have seen that last electron of zinc enters in 3D subshell, completing that 3D with 10 electrons. So after zinc, next 31st electron will enter in 4p orbital. As you can see here, as from the Aufbau's diagram, after 3D, the next orbital is to be filled is 4p. So let us see how these 6 electrons complete this upcoming 4p subshell. So 31 atomic number is gallium, in which the last electron enters in 4p, giving the configuration 4p1. And you can also write in noble gas core. Next is germanium with 32 electrons, and the last 32nd electron will also enter in 4p, but it is in 4py according to Hund's rule of maximum multiplicity, giving the configuration 4p2. 33rd electron of arsenic will also enter in 4p, but it will enter in 4pz, and then giving electronic configuration 4p3. And 34th electron of selenium will enter also in 4p, but now the pairing will start giving 4p4 electronic configuration, and 35th electron of bromine enters in 4p and giving 4p5 configuration, and the last electron of 4p subshell will be of krypton, and it will give the configuration 4p6, thereby completing the 4p subshell now. So here what you observe, when this 4p subshell is completely filled, we have a noble gas named krypton. Next, after krypton, 37th electron, as you can see here from Aufbau's diagram, that after 4p the next subshell is to be filled is 5s. So next 37th electron will enter in 5s, and as we know that s subshell can have just 2 electrons, so after 38th, next 39th electron will enter in which shell? Can you guess now? It will enter in 4D subshell. After 5s, 4D will be filled, because you know that Aufbau's diagram is in increasing order of energy. So next 10 electrons will enter in 4D subshell up to atomic number 48. So let us see the configuration. So in rubidium, 37th electron enters in 5s, giving configuration 5s1, strontium 5s2, and now in noble gas core you will mention krypton first and then the valence shell electron 5s1 and 5s2. Now from 39th element, filling of 4d orbital for 4d subshell will also start. So now next 10 electrons will enter in 4d subshell in the same way as we have done for 3d. Some exceptions you will see just because of the extra stability of half filled or completely filled orbitals. And as you can see here, these 10 elements starting from 39 to 48, yttrium, zirconium, niobium, molybdenum, technetium, ruthenium, rhodium, palladium, silver and cadmium, they have D subshell getting filled as 4D1, 4D2, 4D4 because of extra stability, 4D5, 5s1, then 4d5, 5s2 in technetium, ruthenium 4d7, 5s1, and then 4d8, 5s1, then 4d10, 5s0 in palladium because of extra stability of completely filled 4d10. Silver 4d10, 5s1 and cadmium 4d10, 5s2. So now after completing 4d10, next electron of atomic number 49, where will it enter? Have a look at the Aufbau's diagram. Can you guess now? Yes, now it will enter in 5p subshell. So here we have these next 6 elements having atomic number 49 to 54. Forty-ninth element is indium, in which the 49th electron enters in 5p orbital, 5px actually. Then 50th atomic number 10, 5p2, antimony 51 with 5p3, tellurium 5p4, iodine 53 atomic number 5p5, and xenon 5p6. And now you can see that after completing 5p orbital, next noble gas xenon arrives. So you can have a look at the electronic configuration of these noble gases, and you can find a similarity between these, that they have a completely filled NP subshell. Means valence shell का जो P subshell है, that is getting completely filled in a particular noble gas. So now after xenon, the atomic number 55 and 56, 2 electrons enter in which shell, which subshell? That is 6s, because according to Aufbau diagram, the next higher energy level after 5p is 6s. So after filling of this 6s orbital, the next electrons will enter in 4f, then 5d, 6p, 7s, and then 5f, 6d, 7p accordingly. So up to 118 elements as so far discovered, the 7p orbital gets completely filled. So here in cesium 55 atomic number, the valence electron, last electron enters in 6s1, followed by barium 6s2, and then important 57th electron in lanthanum exceptionally enters in 5d1. According to Aufbau's diagram, it should enter in 4f, but just as an exception, it enters here in 5d. And later on, from 58 to 71, the next 14 electrons will fill 4f orbitals accordingly. And in f orbitals also, you have to follow those extra stability rule. Means whenever there is a possibility of exactly half filled and completely filled electronic configuration, then 4f7 can be there. So it can be D0 shell configuration here, 5d0, as well as 5d1 can also be there, giving exactly half filled or exactly filled configuration. So now we can have a look at periodic table. And as you can see here, the extreme left two groups, first and second group, they have all those elements in which the valence electron enters in S subshell. Starting from 1s, 2s, 3s, 4s, 5s, 6s and 7s gets complete here. And these two groups are called S block elements because the last electron enters in S subshell. And next to the extreme right side, as you can see, the electronic configuration, the valence electron enters in a p orbital. So ranging from p1 to p6, all the electrons enter in p subshell here. As p subshell can have 6 electrons, so there you will find 6 groups, and these 6 groups that are from group number 13 to 18, these are called p block elements, as the last electron or the valence electron enters in p subshell. Then in between these two, you can see 10 groups starting from group 3 to 12. You will see that the last electron or the valence shell is D, 3D, 4D, 5D, 6D. So these 4 series of D elements are called D block elements, in which last electron enters in a D subshell. And the last at the bottom of the periodic table, where you can find two series of 14 elements in which last electron enters in F subshell. These elements are called F block elements. And as you can see in this table, the last group, 18th group, with pink color elements, they will have last electron in mainly in p, except for helium where the last electron has in 1s orbital. So these elements are collectively called as noble gas because they have completely filled outermost shells. Let us see their electronic configurations again. So it's very important to understand and to learn the electronic configuration of noble gases, as whenever you need to write electronic configurations of other elements, you can directly relate that with noble gas, because you know that we can write them in noble gas core as well. So you need to learn first the electronic configurations of all these 6 noble gases: helium, neon, argon, krypton, xenon, radon. So these 6 noble gases, as you can see, except helium, all other have completely filled p orbital, means उस particular शेल का जो p ऑर्बिटल है वो कंप्लीट होता है और एक नोबल गैस के लिए. एंड बाय यूजिंग दीज नोबल गैस कॉन्फ़िगरेशन यू कैन इजीली राइट द इलेक्ट्रॉनिक कॉन्फ़िगरेशंस ऑफ other elements. So learn them properly. Thank you and have a nice day. Practice these electronic configuration, as this is a very important topic to understand the next and the other topics of chemistry.